Okay, so we're back again, and we're going to talk about what happens when we actually want to apply the normal curve to something that is happens in the real world. When we're going out and we're finding things that could be modeled by the normal curve, normally they happen in nature. Things like the length of an elephant trunk, or the height of a giraffe, or um, anything that you can really think about, the width of your nose. All of those things um, could be modeled by a normal distribution. And none of those things have a mean of 0 and a standard deviation of 1. So to be able to solve problems that have means that aren't 0 and standard deviations aren't 1, we have to use the z-score formula. You should put this in your notes. Here's our z-score formula. And that's going to help us standardize our data. It's going to help us do what we are going to refer to as a linear transformation on the data. So let's say that in some population we have a mean of 12 and a standard deviation of 2, and we want to find the probability or proportion of things that would have whatever we are measuring of 15 or more. So let's say maybe just as an example, we're talking about the distance from your elbow to your armpit. And in a normal population, that has a mean of 12 inches and a standard deviation of 2 inches. And we want to find, well, how likely is it that we're going to find somebody that has a length from their elbow to their armpit of at least 15 inches? At least would be 15 or more. Well, I don't see that on the chart. I don't see any way of looking up 15 or having a mean of 12. So what we have to do is transform it. If we think about transforming it by subtraction, we want to get the mean to be 0. Right now the mean is 12. So we can do that by subtracting 12 minus 12. And in doing so, every other point on this curve is going to be subtracted. We're going to subtract 12 from that as well. So when we do that, we're basically just sliding the curve down to 0 by subtracting 12 from everything. And then we notice also now that our standard deviations are not 1, they're going up by 2 still, so we're going to have to adjust for that. We're going to divide by the standard deviation, which is what the z-score formula says, to in effect shrink the curve and give us a standard deviation of 1 where we expect. Now we have a chart that we can use for this curve, but I don't know off the top of my head what this value is anymore. It was 15 way down here, but who knows what this is. So we're going to have to use the z-score to find out. So we want to calculate its z-score. 15, that x value has a z-score associated with it, its distance from the mean, and it's 1.5. Now we're never going to use this model of transformation because it loses all the context. So we want to be able to still talk about lengths from elbows to armpits and talking about people that might have something at least 15 inches. So when we talk about this and we're putting a problem like this into our homework or on a quiz or on a test, we're going to write in context always, and we're going to redraw our picture in terms of that original mean of 12. And because we had to transform it to find the z-score, we're going to include that calculation when the mean isn't 0. And then I have a probability statement, and because this is greater than, I have to do 1 minus we're doing the complementary event. So here's my probability statement, here's my z-score, here's my sketch, and those would be the parts of a good solution. So that's a greater than problem. We can practice also a less than problem. If you're getting the hang of it, I would pause the video and try it out, try to calculate the z-score and sketch and use your probability statement. And I'll give you a second to pause the video, and then once everybody has had a chance to try it, we'll check to see how you did. So now that you're back, we have our shaded value for 60 or 7 or less. We have our z-score calculation, and it's not necessary to show all these steps I'm showing you in the video just to reinforce it, but really we can just show the this substitution step and then say equals 0.6, you have a calculator. And then lastly, our probability statement. When we look up 0.6 on our chart, we can see 0.7257. Another problem for between. So again, we've done a few between problems now. You should understand that we have to calculate two probabilities using two different z-scores. So I'm going to have to do two different z-score calculations. So I'm going to, when I do this, between 2.1 and 1.7, notice that on my curve I actually used the standard deviation and just kind of drew it down. 0.8 less and 0.8 less just to show scale. We could have also just as easily just drawn in a thing and labeled 1.7 and 2.1. It's really up to you. So we're going to pause again. Go ahead and try to calculate this if you haven't yet, and then check again with the video to see if you got it right. So here's our z formula. I'm going to plug in two of these. So if I plug in 1.7, the mean is 3, the standard deviation is 0.8. I get a z-score of negative 1.63 for this x. I do it again for 2.1 and I get a z-score of negative 1.13 for this x. Notice negative 1.13 is further right on the number line. So I'm going to have to look up these respective z-scores to find the likelihood that they would happen or less, always less on our chart. And so I get my probability statement. There's the z-score for negative 1.13 minus the z-score for negative 1.63, and we get a probability of 0.0776. The last kind of that we practiced was looking up the cutoff value. So we have a mean of 89.5 and a standard deviation of 8.4, but we want to look up the score that separates the top 25%. Well, we're thinking about, all right, well, the top 25%, that's the same as the bottom 75% because our curve goes left, and you're saying these things out loud or maybe in your head because you talk to yourself a lot. 25%, 75%, and that little itch in the back of your brain sets off again, and you're like, wait, I know what this is. This is Q3. Oh, man, we found it. We earlier found Q1, now we have Q3. So in our mean of 89.5, we have this curve. We want to find some value that's going to have a cutoff between the top 25% and the bottom 75%. And to do that, we have to look in the body of the table. We're going to look up 0.75, or the closest number we can find to 0.75 in the body of the table. Since we're looking something above the mean, we're on the right side of the chart. And I start trucking around looking for something that's like 0.75. Not a z-score, but a probability. The closest value I came to was 0.7486, which is 0.0014 away, closer than this one. So I look in the rows and columns to find the z-score, and I get 0.67. And then if you look back at your notes, when we did the 25%, the lower 25%, it was negative 0.67. And so you think about the curve folding on itself, it's symmetric, it should have the same distance above or below depending on what we're doing, and that makes sense. That we didn't even have to really look it up if we thought about symmetry, that above the mean is going to be positive 0.67 for 25% cutoff, and then below the mean is going to be negative 0.67, the same distance, just in the other direction. So we're going to use that positive 0.67 in our z-score formula. We plug that in for the z-score. We don't know the x, we don't know the cutoff, whatever that value is, and we know the mean and standard deviation. If I want to solve this equation, I'm going to multiply both sides by 8.4. I'm going to add 89.5 to both sides, and there is the cutoff, somewhere at 0.67 standard deviations above the mean. This would be 25% of the data. You can shade your curve. We don't really need a probability statement since we knew what the probability was ahead of time, top 25 or bottom 75, and we were just looking for the x value. Now on your practice sheet, if you got the practice sheet in class or got it off of my uh, website for school. There are some other problems below that you should practice. You can get into groups and do those. We will talk more about the normal curve next class, but this has been the start and really 1/3 of our unit on the normal curve. Notice that we have a practice day next class and then the review day following. So really a short unit, and we're back to having another test. So it's really important that we practice and do everything we can to get as good at this as possible. Your homework overall, after you practice these problems in your groups, is all odd problems. So you can look up the back of the book and you can look at your answer, but you got to remember that for our class, if you want to get full credit, you're going to have a sketch, you're going to have a probability statement, and if you have a mean that's not 0 and a standard deviation that's not 1, you've got to also include your z-score calculation.